So, studying for the R3 part of the test, if you had this big, scary looking equation, negative parentheses, x minus 3, quantity squared, and then negative x plus 4, yeah, there's another negative in there, then what would the lead term be, and what could it tell you? Imagine this is a test, and they said, what's the lead term? And then tell me all the things it tells you about this function. Mr. Zapp, what do you say?
The lead term is x to the power of 3.
You are correct. What about those negatives they just canceled? Okay. And what does it tell you about this function?
I think it was
Up on the right, down on the left. Good. Well, those are both true, but there's one more thing. What? Ooh, that's one we haven't talked about in a long time. Does it for sure have 2 terms? I want to remind you, x to the third looks like this. So let's talk about the terms, but be careful how you say it. 2 turns is a thing, but what should you actually say? Up to 2 turns, or a maximum of 2 turns. So in other words, this one doesn't have any turns. It just goes up the whole time. Do you get x to the third could also have had a turn like this and another turn like that? That's 2 turns. How do you know which one it is? You don't, unless you actually know the factored form of it, which we do. But anyway, if it's got x to the third, it can't have 3 turns. It could have 2 turns or less than 2 turns. All right, that's a good thing to know. And then there's one more thing you can know from finding this that you didn't have before. You know the end values. It's up on the right, down on the left. That was good. We also know that it could have at most 2 turns, but one more thing you could tell me. It's kind of off the topic. It tells you the degree. Did you get that we didn't have anything here that told us the degree? But this tells us that the degree is 3. Okay, so that's why this is handy to find. You don't have to. Sometimes we just give you this and we say, is it going up or down on the right? And you'd be smart to go figure out that lead term because it tells you a bunch of stuff. It tells you the right, it tells you the left, it tells you the degree. It tells you how many of the max number of turns it could have. All right. All right, so that's one of the tougher things that you have to know. Another one is, do you remember doing this? Synthetic. Let's do a synthetic. Drop it like it's hot, multiply, add, multiply, add. Didn't work. How do I know it didn't work? It has a what? Remainder. If this remainder here had been 0, it would have worked. Well, tell me, what should I have made this number be to make it work? If it would have been -3, do you get it would have worked? All right, I want you to do a little forgery. Change it so it does work. And then this is a 0. And then what are the factors? Like something times something. Do you remember this deal? X minus this. Okay, in case you forgot this, x minus 1 would be the factor for that root. And that 3 is like the end of your little factor. And then this would be your x's. And so it's 2x, and there's no negative on the 3, so it's plus 3. That ring a bell? Do you remember doing that? All right, so if I were studying for this cumulative, I would definitely want to do a few synthetic divisions like that. You know, there's a big bank of problems where we're going to have problems available you can do, and the keys for them to make sure you're doing them right. Definitely want to do some long divisions. Do you remember when there was like placeholders? All right, so let's say I had 2x squared, no, to the third, plus x. Do you get I skipped over the x squareds? Plus 2. Is that a polynomial? Yeah. So if we're doing this in the context of can you do synthetic, there's also long division to consider. Let's do this with just synthetic for now, with a root of 2. Set up and try the long division, and remember there's going to be a placeholder. Because there's missing x squareds, there'll be a placeholder. If you didn't know how to set that up, you better pay attention to how I got that. And then I'm pretty confident that if you have no negatives in there, do you get it's really hard to end up with a 0 at the end? So it's pretty likely not going to work. But if you get the same remainder as the kid next to you, then at least you know you're doing it right. Would you please check that remainder with the kid next to you, see if you get the same thing? There was a remainder of 20. Does that make sense? All right. So what did that mean? That meant that 2 was not a root. All right. Next is, what were the possible roots? Was 2 even one of the possible roots? Well, a question we could ask you, and very likely will ask you on the test, would be, what were the possible roots on this? Like 2 clearly wasn't one of them, but 2 might have been one of the possibles, but it wasn't actually a root. So I told you this in terms of F-con and F-co. Factors of the constant over factors of the what's the co stand for? Coefficient. Very good. And what are the factors of the constant? Plus and minus 1 and plus and minus 2. And don't forget that 1. It's really easy to forget that. And the factors of the coefficient? Also plus and minus 1 and plus and minus 2. Is it as simple as then the answer is plus and minus 1 and 2? No. It's more complicated than that. You could divide each of them by each of them. One divided by 1 is, of course, 1. 2 divided by 1 is, of course, 2. But then 1 divided by 2, it'd be easy to forget. 1/2. And the 2 divided by the 2 gets me back to a 1 again, and I already have it in the list, so there's not much point in saying 1 again. And then, this would be so sad. I'd have to mark it wrong. What'd I forget? Plus and minus. And I could be okay with you doing like that, or putting plus and minus in front of everything, but try to be clear that it's plus and minus of all of those. So when I asked you to check 2, was it unreasonable to try it? No, it was reasonable to try it, but it wasn't it. Do you get that on one of your problems on the test, we actually made you test, and it was like you had to test like 6 things like this, and then eventually one of them finally works? Okay. All right, another skill that was important on that test was, do you remember how to do factor by grouping? Let's see if you do. 2x to the third plus 2x, no, minus 2x squared plus 4x. Does anybody know how I'd have to end this to make it work? Minus 4. All right, go ahead, factor that by grouping. It's one of many key skills you got to know on this test. Now we have this wonderful situation where we finished with all the material in enough time that we can take plenty of time to study for the test on Friday. So today's only Wednesday. We have a whole nother review day. So what I'm going to recommend for today is, as you're kind of like dividing up your study, getting ready, is today I would strongly suggest focusing on studying for these kind, the long division and the any kind of factoring. The part, this is not the rationals part, this is the higher degree polynomials part. So I would try to focus on all your higher degree polynomial difficult problems. And then on Thursday night, I'm going to encourage you to focus on the R3s for the rational function kind of problems, which is mostly graphing really hard rationals, like for weird fraction ones that you have to graph. You got to remember to put the holes in. You got to remember to put the horizontal and the vertical asymptotes in, all that stuff. So anyway, for today, let's focus on these. We haven't even done a single long division yet, so we should definitely do that. All right, did you remember how to do this? Do you agree that 2x squared was in common and therefore factored out? And that left behind an x minus a 1. And then a 4 was in common and left behind an x minus 1. And the fact that they are in common means, yeah, I'm probably doing it right. Then they are the GCF and they come to the front. It doesn't have to be in front, but I think that's the way that makes the most sense. That's the GCF. It comes out to the front. And what's left behind then is 2x squared. And that is positive, so I'm going to say plus 4. Ooh, I just noticed something. Ooh, this would be a great gotcha problem. Did any of you notice that that 2 has to be factored out? Ah, good catch. Now, you could have noticed it at the very beginning that they all had a 2 in them. Do you get it? I could have pulled it out at the front, but you didn't have to. But if you left it just like this, you would lose. The way if I was grading your test, I'd circle that and write factor, and you'd let go, crap, I forgot to factor out the 2. Okay, so another way we can do this question, I'm going to go it this way, is we already know that x minus 1 was a factor of it, right? Let's just stretch your memory on, do you remember how to do long division? Because it's on this test. You might think, well, I'll just use synthetic. You can't always. There are problems that you'd have to do with long division. Basically, if this is anything more complicated than just like x minus 1. Sure, this one right here could be synthetic, but trust me, you have to know how to do long. So let's do one at least. In case this has been too long, I'll remind you, you start with an x, and then you ask yourself, is that going to be enough? X times x makes x squared. No, that's not going to be enough to cancel off that x to the third. And then you realize, oh, I need to make something bigger, more than just x. So what do you think should go there? X squared is close. 2x squared. Because then when you times it by this, you get a match. And then you times it by this, and you get negative 2x squared. And that's weird, but not wrong. It's kind of cool, in fact. Do you remember that deal where you have to change them to both to be the opposites? Minus and plus. If you forgot that, that would have burned you later in the problem. You got to go change it to opposites and then combine them. And yeah, they both drop out. Yay. Drop the 4x. Drop the minus 4. You need, if you have two terms here, you have to have two terms down here. Then you'd go, I guess I need a 4. 4 times the x, 4x. 4 times the negative 1, negative 4. And again, you need to show this opposite, opposite, so that they equal 0 at the end. 0 remainder means that it factored, but it'd be, again, dangerous because the kid would be very tempted to just sum it up and say x minus, just a second, that's a minus for sure, x minus 1 times 2x squared plus 4, and then no. That 2 has to be factored out to the front. Final answer, 2 comes out to the front. X minus 1 can still be there. And then x squared plus 2. There we go. Okay. The last melon then for today is if we get this answer correctly, which we did, I think we've got the right answer now, then that leads to real and imaginary roots. It's been factored, and we can say it equals 0. Do you get that there are some real roots and some imaginary roots? I'm going to remind you, you can do this with some really cool factoring. And some of you pulled this off on the test. Because, see, this x minus 1 just tells me, I can just in my head say, oh, 1 is one of the roots, and 1 is real. And so I've got one real root, and it's 1. But do you remember this deal? X and X, and a plus and a minus. You remember how to finish that? If it just was root 2, just ponder this for a second. If it was just root 2, what would be wrong with that? Why can't it just be root 2? Because when you multiply those last together, wouldn't it be negative root 4, which would be negative 2? That's why it needs an I, and he's right. I root 2 and I root 2. Now, if you don't want to do it that way, you have to remember to get that answer, you're going to go x squared plus 2 needs to equal 0. Minus 2, x squared equals negative 2. How am I going to do that with imaginaries? So then you square root both sides. I do want to finish one like this because there's a few kids that can't factor it that way. So I got to show them. You got to go through it this way then. And then this absolute value is reminding you there's two answers. One positive and one negative. So positive I root 2 and negative I root 2. Okay, so imagine you just got done factoring and you got this. Is that going to leave you with a real root? Yes, what is the real root? Negative 4. Would it be a x-intercept? Yes, it would. Would this be factored all the way? No. You'd have to factor that further. And normally a kid or a teacher would say, yeah, but you can't factor that, so you have to solve it this other way. But I taught you how to factor that. Can you try to get me the real and imaginary roots by factoring it the cool way I just showed you, or setting that equal to 0 and solving it? Real roots, easy. There's multiple real roots, plural. Imaginaries are where the challenge is. I'll pause for a second while you give this a try. Okay, did you come up with x plus 4 led you to a real root of negative 4? This factored to x plus 2 and x minus 2, and that led you to two more real roots. X equals negative 4, X equals 2, and X equals negative 2. I'm being a little over paranoid, but I need you to know you can't just say 4. X equals 4 was fine. All right. The imaginaries, can you factor it this way? X plus and X minus. Because it's one of the ones where it comes out to imaginaries, because there's no way to make that negative 10, really. So then this must be have an I in it. And then it's the square root of 10. Raise your hand if you had that right. Awesome. Then you'll be able to tell me those imaginary roots super easy. You'll be able to just go I root 10. And X equals negative I root 10. But kids that don't know how to factor like that will have to set this equal to 0, X squared equals to negative 10. It's not like it's impossible. I just think the factoring way is way cooler. I root 10, and then this splits into two answers, which again are here. You know what I think I'm going to mark wrong the most is kids that forget to say X equals. Please, please, please. I don't want to mark that wrong, but I have to be fair with my colleagues. I'm making a really big deal about don't give single number answers. Especially happens a lot in AP tests. Because a kid could be a super smart kid, figured out a super hard problem, and they write the answer 5, and then the AP grader says, nope, that doesn't mean anything. Should have been X equals 5. Like, all that work for nothing. Yes?
Isn't it negative 4?
Uh-oh. You are correct. It is negative 4, and I did not have a negative right there. Good catch. Okay. All right, so if I were you today, I would be focusing on, this is called the higher degree polynomials, R3 section. Because those are kind of hard, and we've got enough days now where you can focus on that today, and then tomorrow we will focus on the other part. So look in, I'm going to open it up right now. Stay with me here. Open in Schoology, and then you'll have to hit refresh when I show it to you. Find today's folder. Today is January 8th. And I guess it's in a group folder, so to speak. And all we have right now are the R2 extra practice open. And that goes in that, there is a box where you can drop box that. I allowed you to skip 4 problems off those sheets. I'm going to do the same thing for today, and I am just published it right now. These are the R3 practice, and asking you to do all of those would be kind of abusive, even if we have the time. That's a lot. On this one, given that there's 12 questions, I'd say, I'm going to say again, you can skip. Well, actually, wait a minute. No, not all of these are. Okay, hold that thought a second. We're going to look through and I'll tell you which of them pertain to problems like we just did today. Yeah, for today I'm going to tell you which ones to do. For today you should do number 6. Is that the only one? That could be a small flaw in our studying system here. Holy crap. Am I missing something, or is there only number 6 about? I think you must be seeing the same thing I am. Is there any more than number 6 that are like what we need to practice? Then I'm going to open up something else instead. I'm actually going to leave. You guys saw this, but now you should unsee it. I'm going to not even open it for my other class. So just like delete that document. We're going to do something instead. I'm going to publish this other worksheet, which has way more of the ones that we want to do. And it is called Cumulative 3 Review. Look for the thing called Cumulative 3 Review. this one is pretty much up to number 7. It's the kind that we need to practice. There we go. It would obviously be way too big if I assigned it all, but we're only doing that one kind. So up to problem 7. Just 7 little questions. I know, it's still gonna take time, but you've got time. Problems 1 through 7 on the cumulative review, and that's it. That's all I got for you for today. You work on that. Come up if you have questions. If you want one of your old tests to do corrections on, walk up and ask me about that privately.